everyone, welcome to Studying with Jen. Today we're going to be doing geometric sequences. First things first, what is a geometric sequence? A geometric sequence is when we have a sequence that has a constant ratio between the terms. So in this case, I'm going to call this constant ratio R. To calculate this constant ratio, we take T2 divided by T1. You could also calculate it by taking T3 divided by T2. But the main formula for the constant ratio is Tn plus 1 over Tn. Tn plus 1 is the following term and Tn is the previous term. With geometric sequences, we use the formula Tn is equal to a times by r to the power of n minus 1. Tn being the general formula, the nth term, the general term, all the same thing. A being the first term, T1. R being the constant ratio, the one we calculated over here. And N being the position of the term. This is the main formula we'll be using in this section. One thing to note is what you learnt about sequences as well as exponents in grade 10 and 11 is so important for this section. And if you're not comfortable with that, go practice that stuff before you tackle studying geometric sequences. Okay, let's go straight into examples. My main tip for this is always map everything out and try and calculate the constant ratio first. There might be variables in your constant ratio, but just calculate it and get something for your constant ratio. So in this example, -5, 10, -20, and 40, let's map this out. So our first constant ratio is equal to 10 divided by -5. Here, r is equal to -2. Over here, we have -20 divided by 10. R is equal to -2. Here we have 40 divided by -20. R is equal to -2. So now we have a constant ratio of -2. This is probably the best starting point to have in geometric sequences. Question A asks us to find the formula for the general term. Now we know we normally use Tn is equal to A R n minus 1. Our A value is the first term. So A is this. It's our first term. What is A? -5. Our R value is what we've just calculated is -2 to the power of n minus 1. Now, due to exponent laws, we actually cannot simplify this any further. Why? Because the -5 and the -2 are not the same base, and those negatives must be stuck with those numbers. Do not multiply those negatives together. So this is the final answer. Okay, so question B asks us to calculate the value of the 20th term. 20th is a position. So we immediately say where n is equal to 20. Now, we use the formula we've just calculated. So we're going to say Tn is equal to -5, -2, n minus 1. Wherever you see an n, you're going to put in a 20. So term 20 is equal to -5, -2, 20 minus 1. We can now say term 20 is equal to -5 times by -2 to the power of 19. Then we can put this in our calculator and get a final answer. And the final answer is 2,621,440. And that's our final answer. Okay, so let's have a look at the next example. The next example is 4, 12, 36, 108. Let us map it out. So constant ratio over here is going to be equal to 12 divided by 4, which is equal to 3. Constant ratio here is 36 divided by 12, which is equal to 3. The constant ratio here, 108 divided by 36, is going to be equal to 3. So the constant ratio is 3. They ask us which term is equal to 8,748. First things first, we need to calculate the formula for the general term. To do this, we use Tn is equal to A times R to the n minus 1. Tn is equal to where a is the first term, 4, r is 3, and n minus 1. And that is the formula for the general term. Now, when they've asked which term we want to calculate in the position, we're going to make it equal to 8,748. So, we're going to say 8,748 is equal to 4 times by 3 to the n minus 1. We're going to divide by 4 on both sides, and we get 2,187. That leaves us with 3 to the n minus 1. Now, if you enter 2,187 into your calculator, you press equals, then shift, then where it says fact in yellow, you find out that 2,187 is equal to 3 to the 7 is equal to 3 to the n minus 1. Now, we have a base to the power of something is equal to the base to the power of something. Those bases are the same, we can drop them. So we can say 7 is equal to n minus 1. We add 1 on both sides and we get n is equal to 8. And that's your answer. Okay, so let's go into an example with variables. Here we have k plus 1, k minus 1, 2k minus 5. First things first, what do? We map it out. This constant ratio is going to be equal to k minus 1 divided by k plus 1. This constant ratio is going to be equal to 2k minus 5 divided by k minus 1. Now we can't simplify any of these further. Then the first question asks us to calculate the value of k. We have two constant ratios. These are equal. In a geometric sequence, your constant ratio remains the same. So every constant ratio you work out will always give you the same thing. So we are going to equate them. We are going to say k minus 1 divided by k plus 1 is equal to 2k minus 5 divided by k minus 1. And now we can cross multiply. We say k minus 1 times by k minus 1 is equal to 2k minus 5 multiplied by k plus 1. Once we have this, we have to FOIL everything out. So we're going to say k squared minus k plus 1 is equal to 2k squared minus 5k plus 2k minus 5. I'm going to simplify each side. I'm going to say k squared minus 2k plus 1 is equal to 2k squared minus 5 plus 2 is minus 3k minus 5. Now I'm going to move everything to the right. So I'm going to have 2k squared minus k squared is k squared minus 3k minus negative 2k is minus k, then minus 5 minus 1 is going to be minus 6. Then we can factorize. We get k minus 3, k plus 2. So k is either equal to 3 or k is equal to negative 2. So now we want to determine the possible sequences. So this was the original sequence. We have two values for k, so we will get two different sequences. So where k is equal to 3, term 1 is equal to k plus 1 is going to be equal to 3 plus 1, which is equal to 4. Term 2, which is equal to k minus 1, is going to be equal to 3 minus 1 is equal to 2. Then term 3, which is equal to 2k minus 5, is going to be equal to 2 times 3 minus 5, which is equal to 6 minus 5, which is equal to 1. So where k is equal to 3, the number pattern is 4, 2, and 1. Where k is equal to negative 2, t1 is equal to k plus 1, which is equal to negative 2 plus 1, which is negative 1. T2, which is equal to k minus 1, will be negative 2 minus 1, which is negative 3. And term 3, which is equal to 2k minus 5, is going to be equal to 2 times by negative 2 minus 5, which is equal to negative 4 minus 5, which is equal to negative 9. So where k is equal to negative 2, the number pattern will be negative 1, negative 3, negative 9. And that's the answer. Okay, so let's do a word problem. Here we have the first term of an arithmetic sequence is 3. The third, sixth, and 10th terms form a geometric sequence. Find the value of the constant difference. Okay, so we know T1 is equal to 3. When we add a D, we get T2, which is 3 plus D. We add another D, we get 3 plus 2D. That's term 3. Then, if we had to carry on this pattern, can you see that this is one less of this? And this is one less of that. So, what we're going to do is we're going to say T6 is equal to 3 plus 1 less of 6 is 5D. And T10 is equal to 3 plus 1 less of 10, 9D. So we know that the third, the sixth, and the 10th form a geometric sequence. So we are going to do this completely separately. So the third term was 3 plus 2D. The sixth term was 3 plus 5D. And the 10th term was 3 plus 9D. These are a geometric sequence, so they have a constant ratio. So let's map it out. The ratio is going to be equal to 3 plus 5D over 3 plus 2D. And this constant ratio is going to be equal to 3 plus 9D over 3 plus 5D. Now, because it is a geometric sequence, we know that the ratio stays the same. So these two are equal. So we are going to equate them. We say that 3 plus 5D over 3 plus 2D is equal to 3 plus 9D over 3 plus 5D. Now we can cross multiply. We're going to say 3 plus 5D multiplied by 3 plus 5D is equal to 3 plus 9D multiplied by 3 plus 2D. Now we're going to expand everything. So when we factorize this out, we end up with 9 plus 15D plus 15D plus 25D squared. And on this side, we get 9 plus 27D plus 6D plus 18D squared. Then I'm going to move everything to the left-hand side. I have 25D squared minus 18D squared. That's equal to 7D squared. Then I have 30D minus 33D. That gives us negative 3D. Then I have 9 minus 9, which is 0. I'm going to make that all equal to 0. Then I'm going to substitute out a D. D 7D minus 3 is equal to 0. Now I have two answers for D. D is equal to 0 or D is equal to 3 over 7. D cannot equal 0, therefore we're going to cross it out, and that's our final answer.